For review problem 3.16, we're going to look at a couple of integrals that, had they been assigned in calculus class, you probably would have thrown rocks at your professor, but using the techniques of this class turned out to be fairly straightforward. So for number one, we remember that if I have x is the gamma distribution with parameters r and lambda, that means that the density function f of x equals 1 over gamma of r times lambda to the r times x to the r minus 1 times e to the minus lambda x, as long as x is greater than 0. Now this pretty much matches what I have here. For my problem, my lambda is 2. And I have x to the 17 here, so my r is equal to 18. So that means that the integral from 0 to infinity of 1 over gamma of r, 18, times lambda to the r, so 2 to the 18, times x to the 18 minus 1, times e to the minus lambda x 2x dx, this equals 1, automatic. And so rearranging things, that means that the integral from 0 to infinity of x to the 17 e to the minus 2x dx equals gamma of 18 divided by 2 to the 18th. Now gamma of 18 is 17 factorial, using my rule that gamma of n is n minus 1 factorial as long as I have an integer. So then I just have the small matter of plugging into a calculator and getting this out. And I did this ahead of time. I got 1,356,839,859 and 3/8. And so that's the integral, just simply using properties of the gamma distribution. Okay, for problem number 2, let me rewrite it. That was the integral from 0 to 1, x to the 9th, 1 minus x to the 12th dx. Okay, to do this one, I will use the beta distribution. So if you remember, if x is beta with parameters r and s, then the density function is equal to gamma of r plus s over gamma of r, gamma of s, times x to the r minus 1, 1 minus x to the s minus 1, as long as x is between 0 and 1. Okay, so this lines up quite nicely with my problem here. So for my problem, that means r is equal to 10, and s is going to be equal to 13. So this is going to be equal to, so according to my rules here, this means if I have the integral from 0 to 1 of gamma of r plus s, 23, divided by gamma of 10 times gamma of 13 times x to the 9, 1 minus x to the 12 dx, that is automatically equal to 1. So bringing the constant over to the right-hand side, that means integral from 0 to 1, x to the 9th, 1 minus x to the 12th dx must be equal to gamma of 10 times gamma of 13 all over gamma of 23. Now what's that? That's equal to 9 factorial times 12 factorial over 22 factorial. And then just a matter of plugging into a calculator, and I did this ahead of time. This works out to be 1 over 6,466,460. And so this integral can be done for free because I know the PDF for a beta distribution. Now if this had been an integral from 0 to say 1 1/2, then all bets would have been off.